Hello friends, this is Durga from Technology Mentor / IT University, and we have been seeing quite a few MapReduce programs using Hadoop API, starting from a simple record count application to a full-blown lifecycle implementation for average stock volume per month application. And now we are actually talking about the top 3 stocks by volume on each day to understand the comparator in detail. Comparator can be used for both sorting as well as grouping, so that we can actually sort the data effectively, as well as use the MapReduce APIs to get the ranking of based upon certain key. So far we as part of this application of top 3 stocks by volume, we have developed a mapper. We started with mapper, and then we have defined a driver, and also we have seen how data can be partitioned by default, in which the data cannot means you cannot simulate the global sorting using a default partitioner. And for that reason, we have implemented a custom partitioner simulating the range partition, and we have seen that now data can be sorted in ascending order even when we have more number of reducers by simulating the range partitioning. After that, we want to now start implementing the raw comparator, so that we can leverage our key for sorting as well as grouping, so that we can get data in proper fashion for our reducer. That being said, the comparison is primarily driven by the comparative function, but so far we have created two custom keys, which are custom writable comparable classes, and both of them means this one is actually working on text object, and this one is actually working on long object. And if you look at the comparative function in our method in both the custom writable comparable classes, we are actually deserializing by creating the object long pair and then comparing one sub object at a time. In this case, we have two objects of type long, and first we are comparing the first object of our composite object, and then we are comparing the second object of our composite object. We are doing it in doing at object level using deserialization under the covers. And when you are dealing with too much of data, and the partitioning, comparing, and all those things are very important for your performance, and you should not deserialize into objects to do the comparison. Instead, you should use raw comparators, means you need to simulate the comparison at byte level rather than comparison at object level. So when it comes to text pair, we are trying to store string, and string itself is an object, so there is no other option than writing some very complex writable comparator implementation, and we will see that later. That is not important for this application, but for this application we will try to fine tune the long pair to use byte level comparison as much as possible. In that process, there is an issue with the long pair which we have created earlier as part of average stock volume per month application, and we have been using this long pair for this for the current application top 3 stocks by volume. The issue is unnecessarily we are actually creating objects of type long writable. Instead, long have primitive type for long to store data for long, integer, float, and all. You have primitive data types itself. So if we use primitive data types, we can easily compare data at byte level without deserializing. For that reason, we need to have another copy of long pair. So let me copy it, paste it, and I want to name it as primitive. This should be the original implementation. For now I am creating new class because this long pair is used in average stock volume per month, and if I try to modify that, I have to refactor a lot of code in the existing application as well, which I don't want to do that at this time. For that reason, I am creating a new long pair primitive.java class and just copying the previous one. And here, let me delete all these things. Okay, and let me define two variables by using long data type. Okay, and now it is complaining to implement our three methods: read, fields, write, and compare to. Okay, we will implement those in a moment. First, let us implement getters and setters for this. So right click on the source, generate getters and setters, and I would like to implement those after second. Select all, click OK. So we have the getters and setter methods here. Okay, on top of getter and setter, I want to generate the constructor also. So for that, let me empty constructor is enough, and constructor is required because the framework expects when we actually run as MapReduce application. Once you have the constructor, I also want to generate hash code and equals, and I want to do it after getter and setter methods. Click on OK, and you have the hash code and equals. If you see the hash code logic, it is doing in a different manner compared to I made a mistake. I'm actually making changes to long pair than long pair primitive. So let me do this. Let me copy this and then undo everything in long pair, and then I'm going to long pair primitive, and then I'm pasting that part, and okay, now the errors are going away. Let me refresh this package. Okay, I will come back to that later. Here okay, so let me delete this. Okay, okay, now we have all our code properly, and also I want to implement toString before implementing our read fields, write to, etc. Generate toString, and I want to do it after equals. Click on OK. Okay, now I need to fix this. I don't want to have this type of stuff, and I want to have tab, and then I just want to print the second field. Okay, now we will implement data input, data output, and compare to logic. So for data input, it is simple. So actually, when it comes to so this input and output objects already have read long and write long methods. So what I have to do is this dot first equal to arg0 dot read long. Similarly, this dot second equal to arg0 dot read long. Okay, this is how you can read the fields. And then to write, you have to say arg0 dot write long, and you have to say this dot first. So this dot first will be written as long into HDFS, or pass it over the network by using the serialization under the covers. And then arg.0 write long, this dot second. Okay, now we need to implement the compare to method. For that, I will create a compare method which is a helper class, which will compare the two long objects, two long primitive values. Okay, so this is the logic, and okay, here I need to have long. So what I'm doing is I'm passing two long objects, and then if A is less than B, means if first one is less than B, I'm returning -1. Otherwise, if A equal to B, I'm returning 0, else I'm returning 1. So if A is greater than B, the 1 will be returned. So now I have to say, let me create an long int of variable by name CMP, and then I can say compare. So I'm invoking this method, and I can say first comma o dot first. Okay, and if CMP not equal to 0, then I can say CMP equal to, sorry, if it is 0, then I can say CMP equal to compare of second of o dot second. And now I can actually I'm actually returning the CMP. So using this logic, the data will be sorted in ascending order. If you use minus here, the data will be sorted in descending order of the second field, and if you use minus here, the data will be sorted in descending order of the first field. And here we are already doing at byte level because we are using primitive types. So there is no need to implement complex custom comparators, but still we need to have another class to do grouping comparator, and where we will see how we can leverage leverage this class to develop the comparator, and you will understand more at that time. So now we have created the long pair primitive class, and we will use this as part of our driver as well as the mapper. So now I am going to this class and this package where I have the driver, and then I want to replace all long pair references to the new class. Which is long pair primitive. Okay, and I need to make the changes to the mapper also. And then as we are actually setting directly into long primitive variables, we don't need to create the object here. Okay, this is the appropriate way of creating the keys with primitive types, not the way we have created for text. In case of text, string is itself is a class or object, unlike integer or long. So you need to take a different approach for text pair and a long pair or int pair if you want to create keys for using primitive types. That being said, let us validate this program and make sure that the behavior is same as earlier. So I'm running this, going to run configurations, and then go to arguments, and I want to invoke as output. I want to change the output directly to output 10 and click on run. Okay, I need to make another change. I have to change the partitioner also. So in this also I want to use long pair primitive, and here I have to remove the get because we are directly getting the long value, and here also I have to say long pair primitive. Okay, so now all the changes that are required are done. Now we will run it. Click on run. So now it is executed. Let me go to output 10, and then let me redirect to a consolidated file and let me review it. And you can see that first one is 2012 January 2nd, and next one is 2012 January 3rd after 2012 January 2nd, and then you can say 2013 12/30, so 12/20, so it's after 12/19, and then you can also see that the data is sorted based upon the second field in ascending order, because our comparative function is saying to sort in ascending order. Okay, that being said, let us try to create a grouping comparator also on top using this. For that, I already create a package with name comparators, and here let me create a new class saying long pair primitive grouping comparator. Okay, and for sorting we can just change ascending to descending, so there is not much complexity here. So here we need data in descending order, so we can actually change it to minus, and if you run it for each date, data will be descending order by volume, which is the second field. Okay, so I'm not going to run it again. We will see after creating the grouping comparator, we will run the program again, and then you will see the difference. So let me extend writable comparator here. Okay, now we can say protected. I'm invoking the constructor for this comparator. Super long pair dot class true, long pair primitive dot class. I need to import this one, and then I have to override a method called compare of writable comparable. Click on OK. Here we can actually create two objects of type long pair primitive, which is first, and we can actually typecast Similarly, I can do it for the second one also. Here it is second and here it is B. So I am going out and output 11 ls minus LTR, and you can see the 4 files, and let me consolidate it. And you can see that now the data is in descending order. We got zeros at the end, and the upper you go, you can see that the volume is growing. So the data is actually in descending order. Now, before developing the reducer and wrapping up this video, what we will do is we will generate the jar file, run as maven install, and then copy this to our cluster. Okay, so I am now copying to the cluster. Hadoop. So first I am using both grouping comparator and sorting comparator, and see the counters. We will capture the counters and we will rerun again by removing the grouping comparator, and we will see if there will be any difference. So let me run Hadoop jar. Yeah, this is the one which I want to run, and let me say top 3 0 1, hit enter. Now it is running. So the main piece which you need to look at is the report input groups. Okay, so in this case it should be lesser compared to when we remove the when we remove the grouping comparator from our driver program. So let me go here and comment out in between while it is running, and I am generating the jar file again by doing maven install. This is still running. Let it finish, then we will review. Okay, you can see that input groups are 522, and we have 2 years worth of data, and input group is 1 for each day approximately. So it seems to be working as expected. Now let us go back and remove that run the jar file which is built after removing the comparator. I already commented out this and build the jar file for us. So now I have to come out of this cluster and SCP again, and now the class will not have the grouping comparator while invoking the MapReduce application. So I am logging into the cluster again, and now I am running the program. Here I want to give it as 2. It will take a while. Let's let it finish, then I will review the counters. And now you can see that reduce input groups is much higher, which is 1,119,892 compared to 522. So the number of times reducer will be invoked will be significantly different, because we are grouping a date in this by using grouping comparator. But if you see the reduce input records, it is same in both the cases. Okay, so the number of records remain same, but the number of times reducer function will be invoked is much smaller when we actually use grouping comparator in our case. And also for sorting comparator, we actually change the behavior of comparative function. Instead, if you want to leave it as is, and create a new sorting comparator. You can do that. It's pretty straightforward. You can just copy paste this one and rename it as sorting comparator, and in the sorting comparator what you need to do is so instead of directly written here on the first object, you have to store in CMP in a primitive integer variable, and if it is 0, then I want to say CMP equal to minus, and here I have to say get second, and here I have to say CMP. Now you can use this as your sorting comparator in your program rather than modifying the default comparator behavior. And for that, what we have to do is you can uncomment the grouping comparator, and then you can add one more method here saying job.set sort comparator class, and here you can say long pair primitive sorting comparator dot class. Okay, now instead of using tweaking the default comparator, we can use this additional comparator class to get data in descending order on volume. We don't need to run this. I am pretty sure it will work, and this is how you actually do the develop the comparators for grouping and sorting. If it is for non-primitive objects like text, which is a non-primitive object, in that case you have to have a raw comparator implementation, which you need to deal with byte addresses, which is a little bit complicated, and we will probably see about that when we actually talk about joins. But this is a perfect example to actually understand the grouping and sorting comparator. But don't worry about dealing with non-primitive objects. We will see that elsewhere. And being said that, we will develop our reducer in the next video, where we actually process this descending data which is grouped by date, and then stocks descending by volume size on each and every day, and try to get top 3 stocks with simple reduce code, which is not only simple but also very effective to get the ranking, instead of writing a highly complicated sorting algorithm and then rank the data out of it. Instead, we are using leveraging MapReduce APIs to achieve the desired output. That being said, we will try to close in 1 or 2 videos the entire application. We will validate the results and see how simple it is once you understand all these dots, and try connecting even to implement a highly complex ranking algorithm within MapReduce application. I hope you are enjoying the content so far on my channel. If you like a particular video, please click on the like button. If you want to provide feedback or ask any technical question on a particular video, please leverage the comment section of the video. And if you have not subscribed to my channel yet, please do so. You will see a lot more content than just Hadoop and big data in my channel as we go forward, and the quality also will improve over time for sure. Thank you. Bye.